Well, hello there, and we're back. So, we gave you an overview of the idea of inference. And now let's break down and talk about the two topics that you're going to spend the next bulk of your time discussing. And they're proportions and means. And so, what we're going to do, as we said earlier, is we have this large population, all adults, all teenagers, all college students, all people between the ages of 18 to 29. Do we ever really know how many that is? No, we don't. We know it's millions. But what we do is we take a sample, and the sample is of size n. And so what we're going to do is we're going to do repeated samples of size n. So here's your idea. You have a simple random sample, okay, that you're going to evaluate over and over again, whether you're talking about means or proportions. So you have a simple random sample of size little n from a population big N. And now remember, big N is not a number. Big N is a description, and you have to identify what big N is. So if I want to survey 18 to 29-year-olds about internet use, big N is the number of 18 to 29-year-olds. I don't know what that number is because it's large, but I have to identify it for my reader. I identify what the population is. Then the little n is a number. We define P as the proportion of successes, whatever your success is. Let's say I'm trying to survey 18 to 29-year-olds about how often they use TikTok, right? P is my proportion of successes. Do I ever know P? Not really. We will at the beginning just to kind of help you through it. But for the most part, we use P hat. P hat is the proportion of successes in the sample. Oftentimes, we call the number of successes X, so that P hat becomes X over N. You'll see that description sometimes. Okay, and so basically, this is going to be our life for the proportions. Now, what else do we have? We have mu, which is the mean of the population. So this is the second question, right? What is the average height? We have X bar, which is the mean of the sample. And then for each of these, we have the standard deviation, right? And so we have standard deviation and the standard deviation here. And these are going to be the standard deviations of the sampling distribution. So let's talk about that for just a second. What are we talking about? We're talking about the sampling distribution. And let's just use your common sense a little bit. If you poll 1,000 18 to 29-year-olds about their use of TikTok, are you going to get the same proportion that use TikTok in all of your samples? If you measure the heights of 1,000 18 to 29-year-olds, is that average height of those 1,000 people going to be the same each time? No. And so what we do is we're going to spend time talking about how all of that distribution, okay? So this is the sampling distribution of the sample proportion, P hat, or the sample mean, X bar. So 1, 2. This is our life, okay? And so what we have is we're gonna have some ways to talk about the sampling distribution. And that's basically what we do. So this is your life here. Let's get down some key formulas that you need to know as we work through this. So if you don't have this information, pause it, get this down, and then let's get some formulas out there. Okay, we're back. All right. The way I like to do this is let's look at two columns. Okay, let's look at a column for means and a column for proportion. Okay, and then let's just make a column here of all of our information. Okay, so we have our population. And I think this will be a really helpful summary when we finish this. Okay, so our population for the mean, and our population is of course N. For the mean for the population, we know that's mu. For the proportion, we call that P. Now, we estimate this with our sample, little n. Our sample has mean X bar and proportion P hat. Okay, and remember, we often call that proportion P hat X over N. The mean is, of course, the sum of all the X's divided by N. All right, let's talk about the mean of the sampling distribution. Okay, and so we know, and here's the idea. If we do all of these X bars, and we take the average of all of our X bars, that average should be mu. If we take the mean of all of our P hats, that mean should be P. So let's say I'm going to do 1,000 adults age 18 to 29, how often they use TikTok, or what percentage of them use TikTok, more than a half hour a day. Well, I'm not going to do just one sample, right? I'm probably going to do 50 samples of 1,000 adults, right? And so what's the average of all those proportions? Well, if a couple of cases are met, the average should be P. And let's talk about that. Okay, so this is the mean of the sampling distribution. And I know it's kind of confusing because I'm using mean here and mean up here, but I think you understand what I'm saying. If I take the average of all of these X bars, that should be mu. And if I take the average of all of these P hats, that should be P. This is what we're talking about. Now, provided what? Okay, there's a couple of conditions here. One, we need to make sure that little n is less than or equal to 1/10 of big N. Now, why is that? Well, we don't want our sample to be too large because then it's no longer a sample, right? Then it becomes just survey everyone. So we need to have a small enough sample so that we can take multiple samples, right? If I have 1,000 kids that I'm trying to survey, or let's say I know, for example, my population in a high school is 1,000, and I want to sample students on how much sleep they get at night. My sampling groups need to be smaller than 100 students each, just so that I can have multiple groups, okay? That's how that works. Most of the time this is true because the number of adults is in the millions, right? Hundreds of millions, so you're gonna be fine here. What else do we know? Okay, so we have a couple of things here that we need to know for our standard deviations. Now, we have some standard deviations of the sampling distribution. So now you can kind of see, I think, where this is headed, can't you? We have all these samples, We have an average for all these samples. We're going to calculate a standard deviation for these samples. That's right. There's going to be a normal distribution coming up here. Okay, so I'm going to say sigma sub x bar. Okay, this is going to be the standard deviation of the population divided by the square root of n. Now, again, at the beginning, we're going to pretend to know the standard deviation of the population. Are we going to know that, later on? No, of course not. And we'll change this a little bit. But this is an important first step into learning how to use these formulas. And again, the standard deviation of p hat, the square root of p 1 minus p over n. Okay, provided what now? Okay, provided NP is greater than or equal to 10, and N 1 minus P is greater than or equal to 10. What does that mean? Well, those are just the number of successes. And so this comes back from our binomial distribution work in chapter 6. But basically what we're saying is, if you have 1,000 kids in your high school and you're trying to survey how many of them get more sleep, and you're setting your P, not your P hat, your P at 8 hours, you need to make sure that more than 10 of those students are sleeping for more than 8 hours, or else why bother? And the same thing with, so that's what I'm saying. And so the P here, this would be the proportion. So let's say you want the proportion of students that sleep more than 8 hours. Let's change that just a little bit. You need that P, right? You need the N and the P to be more than 10. So if it's 1,000, you need more than 10%, or more than 1% of the students. So you see what I'm saying? Let's repeat that again. If you have 1,000 students and less than 1% of them get more than 8 hours of sleep, don't bother with your survey. Make sense? So you need NP to be greater than or equal to 10, and then of course the number of failures, N1 minus P, to be greater than or equal to 10 as well. And this number 10 comes from our work of binomial distributions. So let's summarize, okay? 1, we have our population parameters in our sample statistics. We have the mean of the sampling distribution. So in other words, the mean of all of my sample means. That should be the overall mean. And I need the mean of all my sample proportions to be the overall proportion. And so for this first part, again, I know you're wondering, well, why would you bother doing it if you knew the overall proportion? Let's just say I want to know how close my sample is, right? So for example, I know the mean of the SAT for the population, right? We know that the mean of the SAT is 1,000, or it should be. I think it might actually be 1,019 this year, but whatever. What I want to know is, in my sample of 500 kids, what percentage of them scored above or below or within a certain number of points? So that's the mean of the sampling distribution. The standard deviation of the sampling distribution. Well, of course, if I have a bunch of samples, I'm going to have a standard deviation. Those should be centered around the actual mean. This is how we calculate that standard deviation. And for all of this to work, we have to make sure, 1, that my sample is less than 10% of the population, and 2, when I'm dealing with proportions, that both of those are true. And as long as that's the case, we're going to be in good shape. All right, so let's just take a dramatic pause and kind of think about this. And then in our next video, we'll work through some sample problems. Okay? So this is the idea behind the sampling distribution of the sample mean and the sampling distribution of the sample proportion. Keep saying that over and over again. Sampling distribution of the sample mean, sampling distribution of the sample proportion. And again, this all makes more sense once we start to do a few problems, which is in the next video. So have a great day.